Okay, so can you write a global exceptional handling class and capture the all logs in whole application? So basically, how do you write the controller class for global exception handling? What are the steps you follow? And you capture all the logs. And how do you log request and response in a centralized way?
Yeah, so for exception handling, for global exception handling in Spring Boot, we can use add controller advice annotation, and along with that, we can use at the rate of exception handler to create a centralized class for handling all exceptions thrown by controllers. So for that, we can write a class like let's say global exception handler. So on top of that, we will have that at the rate of controller advice annotation, and again inside that we will have the method, the actual method which will be returning the response entity. So on top of that, we can have at the rate of exception handler, and this method will be returning a response entity. So like suppose if we have multiple types of exceptions which we are uh, expecting to happen, let's say resource not found exception or something, so we can write a separate method under this controller advice, this global exception class. And regarding request and response logging in a centralized way, so what we can do is like we can log all these incoming requests using once per request filter. So we can write the class, and that class can extend this once per request filter, and further that will, and this once per request filter will override do filter. There is a method so that it will override, and there further we can add the loggers there. So whatever the logger info debug, whatever level we want, we can add, and we can add the log response status or log details, whatever we want. And for normal logging, we use SLF4J or log4j2 now we can use. And to store logs in a centralized location, we can use like this ELK stack, or I think Grafana also we can use.
Okay, so do you know the basic concepts of deployment related things like AWS, Jenkins, pipeline? Any idea?
Yeah, so we are using Jenkins and AWS in our project. So basically, in we are working on microservices. So they are basically each microservices based on the Spring Boot. So these applications we are independently deploying and developing. So Jenkins we are using for CI/CD pipeline, so continuous integration and deployment. So Jenkins basically it automates like pulling the code from the GitHub, and then we build it using the Maven or Gradle, whatever we are using, and it also runs the unit tests, and it further packages to the .jar or .docker image if we are using the image thing, Docker and all. Then further Jenkins pushes the Docker image to Docker Hub or AWS ECR, and then it triggers deployment like EKS, and then it updates the running container with the new version. So we can see like whole kind of there is a step like the pipeline. We have all the codes are written for this all this. So in some places we have also used EC2 of Amazon AWS. So we can manually deploy the jar or Docker container to EC2. So usually in the first step the developers or us, we write the code and we push the code to GitHub, and then as soon as we push the code, Jenkins fetches it and it builds the jar or Docker image, and then it pushes the Docker image to AWS ECR, and then this uh, deployment scripts runs, and then as soon as the scripts runs, then it updates the ECS, and then app becomes live, and that can be accessible via API gateway or load balancer. We can access that app, any specific URL is there, and also logs, we can go to CloudWatch or ELK to check the logs, and then monitoring can be done via Prometheus or Grafana. So yeah, so these are the steps usually we flow. We usually we follow while the development till deployment. So yeah,
Okay, so you know source control tool, Git and all, right?
yeah, I know that.
Okay. Okay, so what you do? I mean, can you tell me the all the things which you usually do in day-to-day basis regarding Git?
Yeah, initially we first of all we clone. So whatever the Git branch we have to do, we switch to that branch after cloning. So after that, we can whatever changes we want to do to the code, so we can do those changes, and further we can just check the command using git status. So it will show us the whatever changes we have done. So once we have done that, then we can do git add, and if you want to add everything whatever we have changed to push, then we can just say git add dot, then we can say git commit minus m and message we can give, and then git push. So this is the whole flow we follow usually.
Okay, okay, good. Okay, so can you tell me one thing? Have you used Git fetch?
Yeah, I have used that.
Okay, so what is the difference between Git fetch and Git pull?
Okay, so git fetch basically it downloads the changes from the remote wherever we are downloading the source code, but it does not merges that whatever the source code we have fetched into local. But git pull will fetch and it will also merge the changes from the remote to the local branch. So that's the difference.
Okay, let's say we have one scenario. So we made some changes to our code and we have added and we have committed. Okay, so we did git commit. Now I realize that I should not have been committed that. Okay, so I basically want to undo the commit. So what steps we need to follow?
So to undo the commit, actually we have two options. So I mean, one is we can do the soft uncommit. So there is a command, I think reset command is there. So we can do reset soft. We can do so. It will just uh, undo the last commit, but the changes it will keep. And another way is we can do the hard reset. So instead of soft, we can use hard reset, and then it will basically also remove the all the changes what we had done, so that also will be removed. So this way we can do that, and another way is like I mean we can just clone the same code to the different place, and we can start doing the changes. So that is also another way.
So any mistake you are doing, you will simply reclone to a new place. Is it?
No, no, I mean that that is also can be done, but yeah, obviously that is not advisable. That is time taking, and uh, that is not the way we should do. But as I told you, the last solution, that reset command, so that we can use. Yeah,
Okay, what is git ignore? Do you know? Have you seen it?
yeah. Git ignore, basically we can use, there is a file called git ignore, so there we can add all set of uh, commands or keywords we can basically add there, so which we want git to not to track. So basically it tells git which files or directory need to be ignored. So for example, if we have a java code, so there we have a target folder and dot class file, so there can be many things. So those we want it to not to track, so that is why we use it.
Okay, okay. And you know a stash command? Git stash.
Yeah, I know it. So git stash command is like we use it to temporarily save the uncommitted changes.
Okay. Can you tell me the real world application of it? In which situation you have used it?
Yeah, so in which situation means, let's say suppose we are working on some changes, okay, in on our code, and all of a sudden we, for some reason, we are we asked to work on some different bug or some different issue, which we can quickly commit and further we can continue our work. So in this case I have multiple options, like I can go and create the new branch from the master branch and further start working on that, and then further I can switch back to this project. But suppose if I don't want to do that, and that is a very minor change, and I am asked to quickly do the things in this branch only, so in that case what I will do, that I will stash my changes till now. Okay, so I will temporarily save the these changes, so that once I uh, complete the new issue, I mean once I fix the new issue and push the corresponding code, then further I will apply this stash to the my existing code, and I can start working on them again. So yeah, so that's how I have used it.
So you know Spring Data, right?
Spring Data, yeah, I know that. So basically that is the part of Spring module, and it simplifies the data access using repositories. So whenever we are working with relational and NoSQL databases, so we can use it.
Okay, so how you have used it?
Yeah, so basically for that, so we have, let's say, any user class is there or user entity is there, that corresponding data we have in the database, and we want to interact with database. So we can use this user class, and first of all we can create the model layer. Okay, so that entity class, so on top of the user class we have at entity, then on top of id we will have at the rate of id and all, and after that we will have the uh, uh, a controller, and then we will have service layer, and then we will have repository. So in the repository, whatever the uh, I mean for user, we will have the user repository interface, and that will extend the jpa repository. Okay, and in that repository it takes the user, that user whatever the model layer we had created, and along with the whatever the data type of the id. Okay, so that we can give there. And also suppose we have to find the user by name, so we can just say find by username. Okay, so it will automatically fetch that, and if let's say find by email ID, an email ID property is there, so we can simply say that and it will be able to fetch that. So yeah, so we can do that, and we can also do the custom queries, like we can write at the rate of query, and then inside that we can write the usual way how we write the SQL queries, so that we can do. So that is how we use it.
Okay, okay. Okay, what is dependency injection?
Yeah, dependency injection is a uh, design pattern, we can say, that is used to uh, because basically that is used in context of inversion of control, IOC. So the objects are given their dependencies by external entity instead of creating them internally. So basically it is loosely coupled, and we don't have to do any service call. Suppose we are doing into a uh, any class. Earlier we used to do like new of that service, so that is basically tight coupled. Okay, so instead of that, now we can do the loosely coupled using the like various ways, like constructor way and setter injection or field injection. So we can use auto wiring to uh, tell Spring to automatically inject a dependency. So we don't have to make it new of that. That is tightly coupled is not required. So yeah,
Okay, do you know the difference between bean factory and application context? What are they?
yeah. Bean factory is a basic container in Spring. So it lazily loads the bean only when requested, and it is the part of core container. And application context is basically uh, we can say built on top of bean factory, so it has some additional capabilities compared to the bean factory. So it eagerly loads all the singleton beans at a startup and provides many additional features.
Okay, and what are those additional features?
Those additional features are like AOP is there, I remember, so aspect oriented programming. So it supports integrating with the AOP, and then internationalization also has been supported. Yeah, so I mean, I'm not able to recall all of them, but yeah, they have some additional features.
Okay, okay, fine. Okay, can you tell me the spring bean life cycle? Just tell me those steps.
Yeah, so initially instantiation happens, then population of those properties, and after that, uh, uh, bean factory aware callbacks and all happens, and then post construct or after properties set. So those things are executed, and after that, uh, now after this bean is ready to use, and once we it has been used, then pre-destroy or the destroy is called.
Okay, so how many types of bean scopes are there in Spring Boot?
Bean scopes. Uh, they are singleton, prototype, request, session, global session, uh, WebSocket. So yeah,
Okay, can you explain a bit more?
yeah, uh, yeah. So singleton is basically the default scope, and it is basically once instance per Spring IOC container actually. So whatever the singleton object is generated, that is shared across all the application, and prototype is like it is always created new, uh, and every time whenever the bin is requested, so that is a prototype. And then we have a request, so that is like kind of one bin per HTTP request, and then the session happens in the HTTP session, so that happens there. And then in application, so whenever we have the servlet context, so there the one bin per servlet context is there. And then global session is for the web MVC. So similar to session scope, but this global session is shared across all flows in the session. Yeah, so these are the definitions of these types of beans scope.
Okay, so in microservices, what are the key characteristics of the microservices?
That is decentralized. So each team can work on a specific microservices independently, and then different technologies can be used to all different modules whatever is being developed. So we are not stick to a single programming language like we do in monolithic. Also the deployment can happen separately. We are not dependent on the deploying all of the modules at the same time like it happens in the monolithic. And then also if suppose one service fails, then entire system will not malfunction. So for example, suppose one of the section or one of the module of the microservice is failing, so we can apply fault tolerance and we can handle it, like suppose in case of failure how we have to handle it. So those kind of things are not there in monolithic, but here we can do that. So yeah, so these are the mainly key characteristics of the microservices.
Okay, what is service discovery and how do we implement this in a Spring Boot?
Yeah, service discovery is basically that is the process of kind of automatically detecting the service on a network. So we use Eureka for that. So we have Eureka server and Eureka client. So in Eureka server, uh, that that is like kind of acts as the registry. So all the uh, uh, so Eureka server that acts like a registry where the other services can register themselves, and then Eureka clients like they register on the startup and periodically send the like kind of hard bits. So client can also discover other services dynamically through the registry. So as per the requirement in the number of instances of the whatever the services are deployed, so that can be scaled and that can be increased. If the load comes more, then we can have more instances. And whenever the API gateway calls the any service, so at that time the Eureka will is the one which is responsible to send the corresponding IP address to the API gateway. So yeah, so that's what is the working of the discovery services.
Okay, okay. Okay, what are the features of API gateway?
Features like it has many features. So any request which uh, uh, goes from the client, so that goes through the API gateway. Okay, so that is a single entry point. So for all the clients to access the backend microservices, so it has features like load balancing. Okay, and then all the authentication authorization happens here, and then rate limiting also happens, then centralized logging monitoring. Okay, and then routing as I told earlier. So yeah, so these are the features of API gateway are there.
Okay, okay. Okay, so can you tell me the scenarios when you use hash map and when you use concurrent hash map? Maybe in your projects when you use that and why you use that?
Yeah, so in one of my project when I was working on the microservices, so that basically handles the concurrent user sessions. So in that case, I used a concurrent hash map. So there because multiple threads were accessing and modifying the session map. So I use this concurrent hash map. So hash map is not thread safe and concurrent hash map is thread safe, and also it uses the bucket level locking or segment level locking, because initially whenever we have the hash map, so we have the size of 16, so a bucket. So the bin level locking happens, so that basically allows the concurrent read and write. Okay, so we can use this concurrent hash map whenever the thread safety is the scenario, but whenever the uh, we don't want, maybe thread safety is not the major concern, then we can simply use hash map. So for the scenarios when the single threaded operations or simple local caching we have our objective, then we use a hash map. But whenever the scenario is like whenever the multi-thread, in the multi-thread environment, like Spring Beans or session storage we have to use, so we can go with the concurrent hash map. So yeah,
So which one is faster and which one store null keys?
faster will be a hash map, because uh, that we are not waiting for the, I mean, one thread to complete, so all the threads are allowed at the same time. So hashmap is faster. And for null keys, I think in hashmap one null key is allowed, but in concurrent hashmap null keys are not allowed. Yeah.
Okay, okay. So have you faced any memory leak issues in your Java application? And if yes, then how do you fix them? And also tell me, how did you identify it?
Uh, yeah, in one of our older application, which had a kind of a long running batch job, so there we basically observed the heap memory was increasing over time. Okay, so that was the scenario when we observed that, and JVM was not releasing it even after garbage collection. So that memory was always occupied. So basically it was keep on increasing the memory space. So we took a heap dump using the JVisual VM, so we can extract out the heap dump and we can analyze it. So after analyzing, we found that there was a large number of array list and map entries held by a singleton class. So even after the request was over, still that was being occupied. So basically the root cause was that we had a static cache map, but we forgot to remove the entries once processing was done. So to fixing that, we used a weak hash map. So the garbage collection was uh, supposed to collect the entries, and also we changed some of the static to request scope beans, and from that incident, we were able to fix this issue.
Okay, can you explain how garbage collection works in Java?
Yeah, garbage collection, in Java, that happens basically automatically. We don't have to do it manually. So, like in C and C++ and like in those programming languages, we have to do the garbage collection manually. But in JVM, in Java, that has built-in garbage collection process. So that keeps tracking of the objects that are no longer in use, and I mean, regains the memory, and it removes the unused data. So Java basically uses the concept of generational garbage collection. Okay, so there the heap memory is divided into different generations. So we have young generation, old generation, and we have meta space from Java 8 onwards. So young generation is the place where all newly created objects go. Okay, so it's further in young generation. It is divided into Eden and I think survivor space. Okay, so uh, this is the place where most of the objects like keep on dying very quickly. And then we have old generation. So in old generation, objects that survive the multiple garbage collections in the young generation, then those objects are promoted to this old generation. Okay, so this is kind of long lived objects. And then we have meta space, so that store class metadata at a static info. So earlier it was called as permgen. So now from Java 8 onwards, meta space has replaced this permgen and is stored in native memory. So from basically Java 8 onwards, this meta space which has come into picture, so that actually takes the whole space of the place where the Java has been installed. Otherwise, earlier, whenever we had permgen, so at that time we used to give the or we used to increase the memory size using giving like minus x and xms, and we used to give the size of the memory, like how much we want to increase. So yeah, so these are the things what happens behind the scene in Java for garbage collection.
Mhm. Okay. Okay. What is the difference between array list and linked list, and when do you choose which one?
Yeah, both array list and linked list are implementation of list interface in Java, but array list is basically uh, we can use whenever the like random access from the array we have our main objective. But linked list is like whenever our main objective is to the like frequent insertion and deletion if you want. So in that case, we can go for the linked list. So array list has the internal uh, working is like using the dynamic array. So whenever we want to read, so it is very easy to read. But suppose if you want to add any data or read any data, then each node will be shifted to the next node. So it is kind of very much costly. Okay, so this basically takes a lots of time. And in case of linked list, suppose the insertion deletion if you want, so we don't have to shift each node. Instead we can simply so basically the behind the this linked list, the internal working is like using the w linked list. Okay, so that is implemented using w linked list. So if we want to add anything, so we can simply break those nodes links, that next and previous links, and we can simply add the data at the node. Okay, so this insertion deletion will be faster, and in case of linked list, accessing the elements by index is slower. So in that case we should go for the array list. So yeah, so these are the scenarios when we can use it. Yeah.
What is the difference between checked and unchecked exception in Java? And how do you decide that which one to use?
Yeah, checked and unchecked exception basically uh, they are the part of throwable class, and checked exception is basically that happens at compile time. So the compiler forces us to either handle them using the try catch, or we can declare them using throws keyword. Okay, so we have IO exception, SQL exception, file not found exception. So these exceptions are basically compile time. Okay, then coming to unchecked exception. So unchecked exceptions are like the compiler does not force us to handle them, and like whenever we are running the code, so that time itself we got get to know, and we can like we cannot, we have to like it can be like kind of memory level things. So like heap dump and all we have to check, and we have to validate fix them. So those kind of issues will come under this one. So like we have suppose index out of bound exception. Okay, and null pointer exception, illegal argument exception. So all these are the part of the runtime exception. Okay, so that is unchecked exception. So yeah, so this is the difference between these two.
Okay, okay. Okay, what are functional interfaces?
Yeah, functional interfaces is an interface that has only one abstract method and can be used with Lambda expression or method references. So basically, it was introduced in Java 8, and we have annotation called at the rate of functional interface that we can put on top of the interface, and that basically makes sure that that particular interface is following the all the rules of the functional interface. So
Okay, what are the functional interfaces you are aware of which was introduced in Java 8?
Yeah, there are many like runnable, callable, comparator, then functional, consumer, supplier, predicate. Yeah, so all these uh, are the functional interfaces.
Okay, okay. Okay, so what is the difference between transient, volatile, and synchronized keyword?
Transient, volatile, and synchronized.
Yes.
Yeah, so a transient is basically that is used to exclude a variable from the serialization. So suppose we are doing a serialization and any bean class is there and it has many properties and we want one of the properties not to be serialized. So for example, we have username, password, and multiple things. So suppose we don't want password to be synchronized. Okay. So with this password, we can use transient. Okay. So that won't be serialized. And then coming to volatile, so volatile that is used in multi-threading environment. So that is used to ensure the visibility of changes to variables across the threads. So if one thread updates a variable, the changes is immediately visible to other threads. Okay, so that's the use of a volatile. And then synchronized is used to ensure like kind of mutual exclusion. So only one thread can access the block or the method at a time. So like suppose any method is there and we want to make them synchronized. So only one thread at a time will enter inside that block. Okay. So uh, basically synchronized we can say that we use for the thread locking.
Hmm. Okay.